By now, we all know that soap can propel a leaf boat forward, but I needed some answers about this bizarre technology that's threatening to revolutionize the shipping industry. Alright, no, it's not going to do that, but I did wonder if a boat like this could turn around a bend. If so, how far would it travel when placed on a circular track? What shaped boats work the best? And how far and how fast can it go on a long straight track? Shout out to Curiosity Box for sponsoring this video, more about them later. I think the best way to visualize how this works is using some bubble mix and straws. Dipping the straws in, pulling it out, and the film is held up in tension, pulling on all sides. Placing a straw in the middle to divide the regions and now focusing only on the forces acting on this metal straw, and you can see that the forces are balanced so the straw doesn't move. However, if you pop the bubble film on one side of the straw, that tension force is gone and there's a force imbalance that pulls the straw to the other side. And here's another example going the other way. Adding soap to water sort of works in the same way because soapy water has a lower surface tension than regular water. You can see this clearly with some classic demos. Placing a few drops of water down and it has a surface that's quite curved. However, doing so with soapy water and it's much more flat. Another way to show this is using a paper clip which normally sinks in water but can float because of surface tension when carefully placed on top. Adding soap to the water and the surface tension is no longer strong enough to keep the paper clip up and it sinks. You can visualize more clearly how this relates to the boat being propelled using a plate with milk, adding some food dye, and sprinkling some ground pepper on it. Milk does have a lower surface tension than water, but adding soap still decreases it. So adding some soap to the food dye and you create a surface tension gradient that pulls the surface molecules towards the outside of the plate. Adding a few other floating objects and you can see how those objects are moved. Doing this on a larger pan with the same ingredients, and now it's hopefully clear why the leaf is propelled across. That's all great when the leaf is traveling straight, and with the milk instead of water it moves rather slow, so I'm speeding it up here, but I had no proof that it could turn through a bend, and this whole video would be pointless if it can't. So I made a simple turn with Hot Wheels track. To prevent it from leaking, I sealed the holes with plasticine. On the first attempt, the leaf shot off the line, but unfortunately the water wasn't deep enough, so it got stuck right before the turn. After smushing the plasticine down further and replenishing the track, I accidentally dropped a tiny bubble of soap in the water, which wasn't enough to move it, but I was worried the surface tension was weakened, so I went ahead and washed the track again. Trying again, and this time the plasticine wasn't the issue, but rather running into the wall. Also, it's pretty interesting to see this wave that's propagating in front of the boat. I'll show a demo of this without a boat on the long track later. Anyway, trying one more time. This time the leaf started off pretty slow because it didn't get a great start, and then once again got stuck on the plasticine. I was starting to go crazy doing the same thing over and over again and expecting a different result, so I moved on from the unpredictable leaves. I figured I'll 3D print some boats later, but decided to use a piece of styrofoam to confirm that this would work at all before committing to making this video. Placing it on the track and some witchcraft threatened to ruin the experiment as the boat kept turning to the side. What's happening here is actually pretty cool and will be important later, but I just made it smaller and that fixed the issue. On this attempt, I didn't even see any soap hit the water, but as soon as it touched the styrofoam, the boat seemed to move forward while the soap strand was still attached, so I accidentally knocked it back a bit. I thought the trial was over at this point, but then something cool happened that I honestly probably got too excited about. Anyway, despite the setbacks in this terribly flimsy track, I was now feeling confident enough to move on after seeing how well it swerved to bend the corner. To improve on the styrofoam and the leaves, I 3D printed some boat options. Next, I was excited to seal the wood track I made using the mythical product of Flex Seal, which was a childhood dream. To prevent a mess, I thought a single roll of wrapping paper could go underneath, and I was sadly disappointed. Nonetheless, after cursing the wrapping paper company out, I just used some cardboard boxes and was on my way. After coating it thoroughly, I set it aside to dry and began working on the circular track, which I was going to cut out of some foam board. I used some string and a pen to draw a horrible looking circle, which I then had to fix more carefully with a marker. Somehow I broke the scissors cutting the string, but that actually came in clutch later after I used a box cutter to cut out the circles, which was a terrible choice since the box cutter didn't quite make it through the board. Since it was still not budging, I switched to those individual scissor blades, which despite the horrible ergonomics worked okay. Eventually though, and I mean eventually, I got the first circle cut out and just had to do it one more time. With both pieces cut out, I trimmed the wood base down with a jigsaw and glued the foam down using Elmer's glue. I looked it up and it seemed like Flex Seal was going to react with the foam, so I instead sealed this with caulk, and a few days later, both tracks were ready to go. Filling up the long track with some water to confirm that Flex Seal is goated, and I was devastated to find that I was fed Flex Seal propaganda my whole life. To be fair, I don't think I shook it enough, and it definitely didn't help that it was left outside to dry in sub-freezing conditions. Regardless, I had to double down on the Flex Seal, so I got a second can and coated it again. No way it would let me down this time. While that was drying again, I went ahead and tried the circular track. Filling up this track, and caulk appears to be king as no leaks were detected. Adding soap to the first test boat, and I ran into an expected potential problem, which was the boat running into the side. Even after it stopped though, I decided to pick up the boat and try it again on the other side of the track to see if it could keep going. And it turns out the boat does still move very slowly. If that's surprising to you, it's because although the first drop of soap causes the largest surface tension gradient and the biggest push, you can still add more soap to the already contaminated water, or in this case milk, and that higher concentration of soap still produces a similar effect, although it's much weaker. That's why I'm choosing to add the soap directly to the boat and having it flow off. Here's an example on that pan from earlier, and you can see that even after it stops, I can move it, and now with the time lapse, it's still moving in contaminated water. Anyway, here's the rest of the 45-minute time lapse where it finally did come to rest once perpendicular to the edge. For the second attempt, I was hopeful I could fix the turning issue by filling the track up to the very brim. Surface tension will cause the water to be curved just like it is on this dyed water on a penny, and so when something like this speck is floating on that curved surface, it wants to float to the highest point. I think that's what's happening here in the earlier example where the styrofoam was too wide for the curved water on the Hot Wheels track and reoriented to be at the highest point. Anyway, since the boat floats on top, it could act in a similar way and hopefully avoid the walls as it travels. Trying this out again and I ran into a similar issue. Even after trying to course correct, it became clear to me that I was going to need to print a different boat. These ones are not only too big, but they're also so heavy that it's much slower and more lame. In the meantime, I went back to a piece of styrofoam just to see how it would do, and once again, it didn't disappoint. Oh. Oh. The styrofoam was able to stay towards the center as it curved around the track and ultimately ended up making it more than halfway around the track, which beat my expectations before spinning out. It was at this point that I realized I'm an easily amused person, but you would be too if you had to empty, clean, and replenish the tracks in between each attempt. In addition to being easily excited, I'm clearly a very curious person by how far I'm going into this topic, which is a great segue to the sponsor of today's video, the Curiosity Box. The Curiosity Box is an awesome quarterly box created by the YouTuber Vsauce, who I'm sure you all know, and this box is great for anyone who loves science, puzzles, or collecting unique and engaging toys. The first item in this year's spring box was this set of 4 precision milled building bricks made from different metals. And yes, they are compatible with standard bricks. The next item was this nitinol paperclip, which is made of a shape memory alloy. Bending this and you might think the original shape is gone forever, but if you heat it back up, it magically returns to its original shape, and it blows my mind every time I see this. There was also this Omni Jump, which is a wooden game board with 6 different versions of solitaire you can play. This could keep me entertained for hours, as my first attempt I got 3, which made me want to try harder. It also included a t-shirt that's a fun way to make your brain hurt if you look at it for too long. In addition, it had these illusion stickers to go along with it, and they're similarly confusing to the brain. Lastly, it came with this fascinating book that walks you through 50 questions you might have about color. While this spring box is only available until early May or until it sells out, I love the surprise that comes with each new one. This was a box I got last year before they even reached out to sponsor this video, and they also make for great gifts. If you're interested in trying out the Curiosity Box, there's a link in the description for 25% off when you use the code JDS25. Or you can use the QR code shown on the screen. Thanks so much for your support, and now back to the trials on the straight track, which despite 2 layers of Flex Seal still found a way to leak. Although it's not nearly as bad, so it was good enough for some trials. I 3D printed some smaller boats to try, but quickly learned that the smallest ones just sink in water, so this heavy plastic really isn't the move. While filling it up, I couldn't get the water to be all the way to the brim since the ground wasn't perfectly level and the track leaked. I figured that meant I was going to have a heck of a time keeping it straight for so long. As a result, I opted for a rectangular boat to try to align it to be as straight as possible. I'm going to dip this Q-tip in right behind the boat rather than directly add it to the boat, and I want you to pause and guess how far you think this boat will make it down the track. This tape marker is at 1 meter from where the boat will start, just for reference. This first trial isn't a great answer to that question because although it started off pretty good, it ended up brushing against the side, turning the whole thing sharply into the wall, not even making it to the 1 meter mark. The second trial, however, went about as good as it can for a boat of this size without adding the soap directly to the boat. It cruised by the 1 meter mark after about 9 seconds, and as mentioned, this was about as flawless of a run as possible, and it continued down the track. Now it was moving at quite a sluggish pace, so I'll speed it up a bit here, and if you thought it would make it all the way to the end, you'd be wrong. It ended up stopping a bit short, as you can see here. To better see why that happened, I added some ground pepper to the water for the next attempt, and this time, for no particular reason, I used the smallest 3D printed boat that still floats. You can basically ignore the boat on this trial because it had a train wreck of a start, but it's still cool to watch the pepper move down the track. It kept going down the rest of the track just like the boat before, and now you can see that it started to decelerate at about the same distance from the end as a traffic jam of surface molecules and pepper accumulated. Here's a demo I did without a boat so I could watch the wave travel down the track as I referenced earlier. And this wave is definitely moving more quickly than the heavy boat that needs to accelerate. To get a boat that travels closer to this speed and possibly even faster, I switched to thinner styrofoam that I cut from a plate and added a channel where the soap can be placed here towards the front of the interior. This would help keep the effect more localized behind the boat as it moves and prevent it from spreading around the boat as much as possible. This definitely helped the boat accelerate for a longer time and reach a higher speed, but I had some aiming issues still that prevented the boat from reaching the 1 meter mark. At this point, I wanted to try some different variations of this boat design and see the results. I added a little bit of pepper as well. Unfortunately, I absolutely botched this attempt, pulling my hand away too fast, which dropped some more soap on the side, slightly in front of the boat, giving the boat some whiplash to the side. I did like how it gets a boost, almost like it bounces. I honestly don't totally get why this kickback to the left is so fast. Anyway, I moved on to a different shaped boat, thinking maybe some wings could help it course correct automatically. I also added some soap before dropping it. Dropping this in and it almost spun out right off the bat before weaving back and forth, but it did make it past the 1 meter mark, reaching there in about 5 seconds. Then it crashed shortly after. I was definitely happy with the pace of these new boats and wanted to try them back on the circular track. I went with this shape for the first attempt and look at that acceleration. But it was too reckless and spun out 270 degrees before accelerating again over the water in the center. This was still pretty cool as you got to see the water flattening out from the decrease in surface tension and it kind of looked like the boat was plowing the water. This continued for some time, so I'll speed it up a bit here. Upon review, it actually crashed from this loose piece of foam that I somehow didn't see. So I of course removed this for the next trials. I went with a winged approach for the second attempt and sprinkled in some pepper. This trial started off with poor placement into the water right off the bat. I think the fast acceleration is almost a downside for these boats at the start as it makes it more likely for them to run into the wall. But after nudging it back on track, it managed to catch up to the pepper flakes that had already started moving from the initial soap hitting the water. As it did, that pepper began to accelerate again, and as expected, moved faster than the pepper coming the other way, ultimately overpowering that pepper, and although I did have to nudge it, this trial ended up making it all the way around before ending up in the middle again. It didn't seem like the wings helped that much, so I went back to a smaller width boat. It was riding really close to the edge as it went around, but managed to avoid actually getting caught on it, well, until it didn't. I tried to save it, but was unsuccessful. I actually stopped recording, and it managed to start going the other way, so I started filming again, and then I saw a spectator. I decided to switch back to a larger styrofoam piece, and wanted to try a channel in one of these bigger pieces. Although being faster is cooler, it definitely doesn't help it stay on the track, and I really wanted to complete a full lap without having to nudge it. As expected, when this heavier boat dropped in, it didn't start out as fast. However, it did ride along the edge for quite a while, and once it made it about 3/4 of the way, it started to look like it was in some trouble, but it managed to avoid hitting the inner wall and kept going very slowly now, and I just needed it to get to this drop for a full lap to be complete, so speeding it up, and yes, it did complete a full lap. 130 gigabytes of footage later that I edited down into this video, and I hope you enjoyed. If you did and want to consider directly supporting my exploration of other topics, consider buying me a coffee. You can find a link to do so in the description. Thanks for watching to the end, and I'll see you next time.